NASA stands at the forefront of space exploration, constantly pushing the boundaries of what's possible. In the coming years, the agency has lined up an ambitious series of projects that promise to redefine our understanding of the universe. From returning to the moon to reaching out to distant planets, NASA's roadmap is filled with innovation and excitement. In this video, we'll take you through the most anticipated upcoming projects, exploring their goals, technologies, and the impact they could have on science and humanity. Let's embark on this journey together and see what the future holds for space exploration. Artemis program marks NASA's bold return to the moon. Unlike the Apollo missions, Artemis aims to establish a sustainable human presence on the lunar surface. The first crewed mission, Artemis II, is set to orbit the moon, paving the way for Artemis III, which will land astronauts, including the first woman and person of color, on the lunar South Pole. This initiative is not just about exploration, it's about building the foundation for future missions to Mars and beyond. Artemis represents a new era of lunar science and international collaboration. Key component of the Artemis program is the Gateway, a small space station that will orbit the moon. The Gateway will serve as a staging point for lunar landings, scientific research, and deep space missions. Its modular design allows for international partners to contribute, making it a truly global effort. The Gateway will also test new technologies for life support, propulsion, and communication, all critical for future Mars expedition. This outpost is set to revolutionize how we explore not just the moon, but the entire solar system. NASA's Volatiles Investigating Polar Exploration Rover, or VAPOR, is set to explore the moon's south pole in search of water ice. This mobile robot will map resources that could support future human missions, such as drinking water and rocket fuel. VAPOR's findings will help scientists understand the distribution of water on the moon and how it can be extracted and used. This mission is crucial for establishing a long-term human presence on the lunar surface and for planning sustainable exploration beyond Earth. One of NASA's most ambitious projects is the Mars Sample Return Mission. In partnership with the European Space Agency, NASA plans to bring back samples from the Martian surface for the first time. The Perseverance rover is already collecting samples, which will be picked up by a future lander and launched into Mars orbit. From there, another spacecraft will return them to Earth. Analyzing these samples could answer fundamental questions about life on Mars and the planet's history. NASA's Europa Clipper mission is set to launch in the coming years to study Jupiter's icy moon Europa. Scientists believe Europa's subsurface ocean could harbor conditions suitable for life. The spacecraft will conduct dozens of flybys, analyzing the moon's surface and atmosphere with advanced instruments. By studying Europa's ice shell and potential water plumes, the mission hopes to uncover clues about the moon's habitability and the possibility of life beyond Earth. Dragonfly is an innovative rotorcraft mission to Saturn's largest moon, Titan. Unlike traditional rovers, Dragonfly will fly from site to site, exploring Titan's diverse landscapes, including dunes, lakes, and possible cryovolcanoes. Titan's thick atmosphere and organic-rich surface make it a fascinating target for studying prebiotic chemistry and the building blocks of life. Dragonfly's unique mobility will allow it to cover more ground than any previous planetary mission. James Webb Space Telescope, NASA's flagship observatory, is already transforming our view of the universe, but its upcoming observations promise even more discoveries. Webb will peer deeper into space and time than ever before, studying the formation of stars, galaxies, and planetary systems. Its advanced instruments will also analyze exoplanet atmospheres, searching for signs of habitability. Webb's findings will shape our understanding of the cosmos for decades to come. Nancy Grace Roman Space Telescope, set to launch in the next few years, will survey vast areas of the sky with unprecedented detail. Its wide-field view will help astronomers study dark energy exoplanets and the structure of the universe. By capturing millions of galaxies and stars in a single shot, the Roman telescope will complement the discoveries of Hubble and Webb, offering new insights into cosmic evolution and the mysteries of space. NASA's Psyche mission will visit a unique asteroid made mostly of metal, located between Mars and Jupiter. Scientists believe Psyche could be the exposed core of an early planet, offering a rare glimpse into planetary formation. The spacecraft will orbit the asteroid, mapping its surface and analyzing its composition. By studying Psyche, NASA hopes to unlock secrets about the building blocks of planets and the history of our solar system. DAVINCI mission will send a probe through the thick atmosphere of Venus, descending all the way to the planet's surface. This daring journey will measure atmospheric composition, pressure, and temperature, providing clues about Venus's history and why it evolved so differently from Earth. DAVINCI's data could help scientists understand the potential for habitability on rocky planets and the processes that shape planetary environment. VERITAS is another upcoming mission to Venus, focused on mapping the planet's surface in high resolution. Using radar and infrared sensors, VERITAS will reveal Venus's geological history, searching for evidence of active volcanoes and tectonic activity. This mission will help scientists understand why Venus became so inhospitable and what it can teach us about Earth's own geological evolution. SPHEREx is a space telescope designed to survey the entire sky in infrared light. Its mission is to map the composition of galaxies, stars, and planetary systems, searching for the building blocks of life. SPHEREx will also investigate the origins of water and organic molecules in the universe, helping scientists piece together the story of cosmic evolution and the conditions that led to life on Earth. NISAR, a joint mission with the Indian Space Research Organization, will use advanced radar to monitor changes on Earth's surface. From tracking earthquakes and volcanoes to studying glaciers and forests, NISAR will provide valuable data for understanding our planet's dynamic systems. This mission will help scientists predict natural disasters, manage resources, and address the challenges of climate change. OSIRIS is on a mission to visit a group of asteroids known as the Trojans, which share Jupiter's orbit around the Sun. These ancient objects are thought to be remnants from the early solar system. By studying their composition and structure, Lucy will help scientists understand how planets formed and why our solar system looks the way it does today. The mission's unique trajectory will allow it to visit multiple asteroids over a 12-year journey. After successfully returning samples from asteroid Bennu, the OSIRIS-APEX spacecraft is now heading toward Apophis, a near-Earth asteroid. Renamed OSIRIS-APEX, the mission will study Apophis up close when it makes a close approach to Earth in 2029. Scientists hope to learn more about the asteroid's structure, composition, and potential hazards, contributing to planetary defense efforts and our understanding of near-Earth objects. NASA is planning a next-generation space telescope, the Habitable Worlds Observatory, to search for Earth-like planets around other stars. This ambitious project will use advanced optics and imaging techniques to directly observe exoplanets and analyze their atmospheres for signs of life. The observatory will build on the legacy of Hubble and Webb, pushing the boundaries of our search for habitable worlds beyond our solar system. Lunar Trailblazer is a small satellite mission designed to map water on the Moon's surface. Using advanced spectrometers, it will identify the locations and forms of lunar water, helping scientists understand how water is distributed and how it changes over time. This information is vital for future lunar exploration and for developing technologies to use lunar resources for human missions. Interstellar Mapping and Acceleration Probe, or IMAP, will study the boundary where the solar wind meets interstellar space. By analyzing particles and magnetic fields, IMAP will help scientists understand how our solar system interacts with the galaxy. This mission will provide new insights into space weather, cosmic rays, and the protective bubble that shields Earth from harmful radiation. Nancy Grace Roman Space Telescope will also test a powerful new Coronagraph, a device that blocks starlight to reveal faint exoplanets. This technology demonstration will pave the way for future missions to directly image Earth-like worlds. By perfecting these techniques, NASA hopes to make groundbreaking discoveries about planets orbiting distant stars and the potential for life elsewhere in the universe. Mars Ice Mapper is a proposed mission to map water ice deposits on Mars. By using radar from orbit, the spacecraft will locate accessible ice that could support future human explorers. Understanding where water is located on Mars is crucial for planning sustainable missions and for the search for past or present life. This mission will help pave the way for human settlement on the Red Planet. AstroBee is a family of free-flying robots designed to assist astronauts on the International Space Station. These smart robots can perform routine tasks, monitor the environment, and even help with scientific experiments. AstroBee demonstrates how robotics and artificial intelligence can make space missions safer and more efficient, paving the way for future autonomous systems in deep space exploration. NASA's X-59 QSSD is an experimental aircraft designed to demonstrate quiet supersonic flight. By reducing the sonic boom to a gentle thump, the X-59 could revolutionize air travel, making supersonic flights over land possible. This project combines cutting-edge aerodynamics materials and noise reduction technologies, showcasing NASA's commitment to advancing both space and aviation innovation. NASA's Commercial Lunar Payload Services (CLPS) program partners with private companies to deliver science and technology payloads to the Moon. These missions will test new landers, rovers, and instruments, supporting Artemis and future lunar exploration. By working with industry, NASA accelerates innovation and opens new opportunities for commercial space activities. Support the Gateway Lunar Outpost. NASA has established Gateway Logistics Services. These missions will deliver supplies, equipment, and experiments to the lunar station, ensuring astronauts have what they need for extended stays. Reliable logistics are essential for sustainable lunar exploration and for building the infrastructure needed for missions to Mars and beyond. NASA's Deep Space Network is the backbone of communication with spacecraft across the solar system. Upcoming upgrades will enhance its capacity, speed, and reliability, supporting a growing fleet of missions. With more powerful antennas and advanced data processing, the network will ensure that scientists and engineers can communicate with distant probes and receive critical data in real time. Space Launch System (SLS) is NASA's most powerful rocket designed to carry astronauts and cargo beyond Earth. Future upgrades will increase its lifting capacity and flexibility, enabling more ambitious missions to the Moon, Mars, and deep space. The evolution of SLS will be key to supporting NASA's long-term exploration goals and expanding humanity's reach into the cosmos. Orion spacecraft is NASA's next-generation vehicle for deep space exploration. Designed for crewed missions to the Moon and beyond, Orion features advanced life support, navigation, and safety systems. Upcoming upgrades will improve its performance and reliability, ensuring astronauts can travel farther and stay longer in space. Orion is central to NASA's plans for human exploration of the solar system. NASA's Lunar Surface Innovation Initiative focuses on developing new technologies for living and working on the Moon. From advanced habitats and power systems to autonomous construction and resource extraction, this initiative aims to make lunar exploration sustainable and self-sufficient. The technologies developed here will also benefit future missions to Mars and other destinations. Ingenuity, the small helicopter that flew on Mars, has paved the way for future aerial exploration of other planets. NASA is planning more advanced rotorcraft for Mars and beyond, using lessons learned from Ingenuity's flights. These aerial vehicles will scout terrain, assist rovers, and explore areas that are otherwise inaccessible, expanding our ability to study alien worlds. NASA's Exoplanet Exploration Program is dedicated to finding and studying planets beyond our solar system. Using a combination of space telescopes and ground-based observatories, the program searches for Earth-like worlds and analyzes their atmospheres for signs of habitability. upcoming missions will use new techniques to discover smaller, more distant exoplanets, bringing us closer to answering the age-old question, are we alone? Astrophysics Pioneers program supports small, innovative missions that tackle big questions in astronomy. These projects use cutting-edge technology to study everything from black holes and neutrons, stars to the cosmic microwave background. By funding creative ideas and rapid development, NASA accelerates scientific discovery and trains the next generation of space scientists. Solar Cruiser is an experimental mission to demonstrate solar sail technology. By harnessing the pressure of sunlight, the spacecraft can travel without traditional fuel, opening new possibilities for long-duration missions. Solar Cruiser will study the sun's environment and test how solar sails can be used for future exploration of the inner solar system. NASA's CubeSat launch initiative provides opportunities for small satellites to hitch a ride on larger missions. These tiny spacecraft are used for technology demonstrations, Earth observation, and space science. By supporting CubeSats, NASA encourages innovation and gives students, researchers, and startups a chance to participate in space exploration. NASA is enhancing its ability to predict space weather, which can affect satellites, astronauts, and even power grids on Earth. New missions and instruments will monitor solar activity, track space storms, and provide real-time data to protect technology and infrastructure. Improved space weather forecasting is essential for the safety of future deep space missions. NASA is developing next-generation spacesuits for lunar and Martian exploration. These new suits will offer greater mobility, durability, and life support, enabling astronauts to work safely in harsh environments. Advanced materials and smart systems will make spacewalks more efficient and comfortable, supporting longer and more ambitious missions. NASA is working with commercial partners to develop new human landing systems for the Moon. These landers will transport astronauts from lunar orbit to the surface and back, supporting Artemis and future exploration. By fostering competition and innovation, NASA aims to create safe, reliable, and cost-effective vehicles for human spaceflight. NASA's Planetary Defense Coordination Office is leading efforts to detect and track near-Earth objects that could pose a threat to our planet. Upcoming missions will test ways to deflect asteroids and improve our ability to predict potential impacts. Planetary defense is a vital part of ensuring the safety of Earth and advancing our understanding of the solar system. Reliable communication is essential for lunar exploration. NASA is developing new relay satellites and ground stations to ensure astronauts and robots can stay connected on the Moon. These systems will support navigation, data transfer, and emergency response, making lunar missions safer and more efficient. Support long-duration missions to the Moon and Mars. NASA is developing advanced nuclear power systems. These reactors will provide reliable energy for habitats, rovers, and scientific instruments, even in environments where solar power is limited. Nuclear power is a game-changer for deep space exploration, enabling missions that were once impossible. Astrobiology is at the heart of many NASA missions, from Mars to the icy moons of Jupiter and Saturn. Scientists are searching for signs of life, studying extreme environments, and developing new instruments to detect biosignatures. The discoveries made in the coming years could transform our understanding of life in the universe and our place within it. NASA is investing in the design and testing of advanced space habitats for future missions. These living quarters will provide astronauts with safety, comfort, and the resources needed for long stays on the Moon, Mars, or deep space. Innovations in habitat design will make it possible for humans to live and work farther from Earth than ever before. One of NASA's goals is to use resources found on the Moon to support exploration. Technologies for extracting water, oxygen, and building materials from lunar soil are being developed and tested. Resource utilization will reduce the need to transport supplies from Earth, making lunar missions more sustainable and affordable. NASA's upcoming projects are increasingly global, with international partners contributing spacecraft, instruments, and expertise. Collaborations with agencies like ESA, JAXA, and ISRO expand the scope and impact of missions, fostering a spirit of unity in exploring the cosmos. These partnerships make ambitious goals achievable and ensure that the benefits of space exploration are shared worldwide. As we look ahead, NASA's upcoming projects promise to usher in a new era of discovery and innovation. From the Moon and Mars to the farthest reaches of the solar system, these missions will expand our knowledge, inspire future generations, and bring humanity closer together. The journey is just beginning, and the possibilities are as limitless as the universe itself. Stay tuned as NASA continues to reach for the stars and beyond.